ACNFers. Many of you know I love to crack open a beer on this pod. Sometimes it contains alcohol, sometimes it's a near beer, and I've been selected as a brand ambassador for Athletic Brewing for the better part of a year, who knows, maybe longer. This brewery, they make my favorite non-alcoholic beer. Shout out to Free Wave, their hazy IPA. I drank my last one yesterday, so I need more. If you use the promo code BrendanO20 at checkout, you get 20% off your first order. Head to athleticbrewing.com and order yourself some of the best non-alcoholic beer you'll ever drink. I mean it. Also, I don't get any money. I get points towards flair and points towards beer purchases, but like no actual dollars and cents. All right? Go check it out.
Denying that there's climate change. I mean, that just, it makes me chuckle because, I mean, you're denying that thermometers work.
Oh, hey, it's the Creative Nonfiction Podcast, CNF Pod, for those in the know. The show where I speak to badass people about the art and craft of telling true stories. I'm Brendan O'Mara. How's it going? Today's guest is a returner, Steve Brusatte. Yes. I think he's at Steve Brusatte on Twitter. Don't quote me on that. He's the author of The Rise and Fall of the Dinosaurs from 2018. His latest book, though, is Rise and Reign of the Mammals. We talked about dinos last time, and this time we talk about mammals. Hey, that's us. Convergent evolution, how Steve pivoted a large part of his research from dinosaurs to mammals, and how we might learn from past climate events to potentially address our current man-made climate disaster. It's all in the book. It's a big, meaty survey on mammals. If you love pop science books, you're going to love this one, man. Steve's a professor and a researcher at the University of Edinburgh in Scotland. I think I'm saying that right. No accent, because he grew up in Illinois, a Bears fan, poor guy. Actually, he was a sports writer for a time before he turned his gaze to bones. Show notes to this episode and a billion others are at BrendanO'Mara.com. Hey, there you can also sign up to my Up to 11. You can sign up for my Up to 11 Rage Against the Algorithm newsletter. This is where it's at, CNFers. I'm not one to hang out on social media, but I am one to put a lot of effort into my kick-ass, permission-based newsletter. Entertains, I think it gives you value, and sticks it to the algorithm, right up the algorithm's keister. If that's your thing, go ahead and sign up. Been doing it for many, many years. First of the month, no spam. As far as I can tell, you can't beat it. Oh, I'm getting really good at these intros. They're starting to get tight, man. Really tight. I say that because we're going to get right into this conversation right now with Steve Brusatte about the rise and the reign of mammals. Huh. Absolutely, yeah. I think a good place, a good jumping off point might be is to talk about your encounter with Tom Williamson and how that effectively kind of changed some of the trajectory of your career in the paleontology that you are really sinking your teeth into now.
Tom Williamson, he's a dear friend and colleague of mine, and we've worked together quite a long time now. And I credit Tom completely with getting me into mammals. I mean, I've always been interested in mammals just in general because, well, I am a mammal. and,
Yep.
and, when I when I was growing up in Illinois and as a teenager and I was fascinated with dinosaurs, I learned very quickly that nobody had ever found a dinosaur fossil in Illinois. And that's still the case. And, it's just not the kind of place that preserves dinosaur bones. It doesn't have the right type of rocks. But there were lots of woolly mammoths and giant ground sloths and other fossils of these ice age megafauna mammals that people would find, that farmers would find when they were out working the fields, or construction workers would find when they were laying foundations for buildings. So, I was interested in mammals generally for those reasons, but it was Tom that helped make me see that mammals were also worthy of scientific study, which sounds weird. Of course they're worthy of scientific study, but people have been studying them forever. We want to understand our own origins. How do we do that? We study other mammals. But I was so obsessed with dinosaurs when I was a young scientist that I was, really too hyper focused. And Tom, he showed me the light. And my first encounter with Tom was actually when I was in high school. I sent him some emails because Tom also studies dinosaurs, and Tom was the guy who CAT scanned a skull of a duck-billed dinosaur and worked with some physicists to reconstruct what that dinosaur would have sounded like by doing these computer models of airflow through the nasal cavities. And that was really like exciting work, and I thought that was so cool. So I sent him some emails and kind of got to know him a little bit. And I wanted to get a tour of the museum in New Mexico in Albuquerque when I passed through on a family vacation in 2001. And Tom said, yeah, I should be around, if you tour. We showed up and we ccalled his office and he didn't pick up. He ended up not being in that day, which was, I was like, man, this is so disappointing. This guy, Williamson, and, but little did I know that a few years later I would, run into Tom again and at a conference. It was actually a conference about tyrannosaurs. And I was presenting some work that I did as an undergraduate with my professor, Paul Serino, who taught me, a lot about dinosaurs. It took me on my first dinosaur digs and so on. And he couldn't go to this conference, so he asked if I could present this work on his behalf. And I went there, and Tom was there, and Tom also studies tyrannosaurs. Tom studies a lot of stuff. And so we got to know each other well there, and became friendly. I was a college student. Tom was a curator at a museum, but he wasn't, particularly, a graybeard or anything. He was a younger curator. And just from there, we struck up a friendship, and we kept seeing each other at other conferences and so on. And before long, nearly a few years later, we were chatting at one of these conferences, and I had just done some work on, I just done a study on dinosaurs using some new statistical methods to study the origin of dinosaurs, how quickly dinosaurs evolved, and how their bodies were changing way back in the Triassic period, and what that tells us about, where dinosaurs came from and how they took over the world and so on. And Tom said, you should do this with mammals. And I said, wow, okay, maybe. And as I knew, but didn't really give much credence to at the time, was that Tom also studied mammals, and he particularly studied these mammals that lived right after the duck-billed dinosaurs and the tyrannosaurs went extinct, the ones that were living in the Paleocene period, that interval of time after the asteroid hit and knocked off the dinosaurs. So I knew Tom studied these mammals, but I just didn't know much about them. And he told me, he kind of sat me down and was telling, laid it out and said, we got all these fossils. These mammals are living after one of the worst mass extinctions of Earth history. These mammals are our ancestors. This is when we see the real first placental mammals in the fossil record, the ones like us and dogs and cats and elephants and whales and so on that give live birth to big babies. This is like an evolutionary diversification of the most important degree. This is our diversification. Let's use these methods to study these mammals. And so from that point on, really, Tom, he laid out the gospel on me, and I just started to learn more about those mammals. At that time, I was a PhD student studying dinosaurs. I was still studying dinosaurs. I did my PhD on dinosaurs. But when I finished my PhD and I moved to Edinburgh to take my job here on the faculty at the University of Edinburgh, one of the first things I did, as a new faculty member, you need to scout out new projects. You need to start applying for research grants. You need to start building new teams to address new questions, new mysteries. You're going off trying to do something different from your PhD. And I asked Tom, I said, you want to do this now? You want to properly do mammals using some of these statistical methods? And he said, yeah, we'll collect new fossils. You can come out to New Mexico. We'll study these mammals together. And that's really what led to both, in a scientific sense and also as a writer, becoming interested in mammals. So I've, written The Rise and Reign of the Mammals now, this pop science book all about mammal history, the 325 million years that's led to us. But also as a scientist, a lot of my research now is on mammals. A lot of the research studies that I do in my lab and with my students are with Tom and with other mammal researchers. And that's what we've been doing recently. I mean, just like last week, we published this new study, looking at the teeth of some of these mammals from New Mexico. We were able to tell using chemical fingerprinting. We were able to tell that these
Huh.
mammals raised their babies for 7 months in the womb, and their babies drank milk for 1 or 2 months, and then they became mature and started to have their own babies about a year later. I mean, we just published that like last week. So most of the work in my lab right now is about mammals and is with Tom, and it all goes back to those conversations many years ago. So that's a roundabout way of answering the question and giving Tom all the praise and all the credit that he deserves.
Now, when I've spoken with past professors of mine, and I came up as a journalist, cutting my teeth as a sports writer, and that can be, and I still do some sports writing, but it's a very crowded place. And one professor was like, you should to like diversify your writing. You could go into science writing because it's just not quite as crowded, and it's a little versus sports, and it's something that I definitely want to do and haven't really gone into as much. But your pivot to more mammalian research made me think of, it brought that anecdote back up to me, and I was wondering if maybe just from a career perspective, it was pivoting to mammals something where you could carve out more of your own turf.
Yeah, I think you're spot on there. There's a few. I can't remember, by the way, if when we chatted last time, if we talked about how I started as a writer. But I started as a writer, as a sports writer for my, small.
Oh shoot! I didn't know that. No, I don't think that came up.
Yeah, back in Ottawa, Illinois, where I grew up. It's a small town. It's about 20,000 people. It's about 75 miles from Chicago, out past the suburbs. Out in the cornfields and the bean fields. A great place to grow up. And we have a newspaper there. It's called The Times. And my family, we knew the editor, Lonnie Kane, and I was big into sports as a kid, still am, and I always loved to write in school, and so I badgered Lonnie every time we saw him. When I was around the time of starting high school. A summer job. You have a summer job in the paper, and he got me one. At very minimum wage, doing like the box scores for the little league games and the volleyball games and so on. But then for 4 years I worked at the paper and kind of just worked my way up in just to writing sports articles and then doing features and so on. And it was working in the newsroom around real writers, real journalists, people that actually had real training and real credentials. And this was their job. This was their craft. That's how I really learned how to write, and I learned how to work with editors, and I learned how to write to deadline and how to cut through a lot of noise to find a storyline and so on. So anyway, that's a total aside to your question, but just to say that, sports writing is kind of where I started. And I don't know, maybe you can see some of it in how I write about prehistory with some of these, competitions.
Well, some of the play-by-play,
Yes,
there is there's an action.
Exactly.
There's an element of that.
But to actually answer your real question, there's a couple reasons why, both as a scientist and a writer, I pivoted more toward mammals. First of all, I still do study dinosaurs. I will always study dinosaurs. I love dinosaurs. That is my fundamental expertise as a scientist. It is what I studied as an undergrad, cutting my teeth, on fossils. It's what I learned how to dig up, dinosaur bones first, and then I did my PhD on dinosaurs and so on. So I'll continue to study dinosaurs, but it's really that I've expanded out to now also study mammals. And in part, it is because that the more I studied dinosaurs, the more I started to wonder what happened after the dinosaurs died. And with getting to know Tom better and just talking with Tom and working with Tom, I mean, it was obvious it was mammals, but it wasn't just, it was mammals. It was, well, Tom has all of these fossils he's collected. He knows these mammals. So, scientifically, I think it was just a natural evolution rather than just sticking within dinosaurs to going further. I mean, the evolution of life is a 4 billion year old story. And, the dinosaurs had their day and it ended. And I've studied the dinosaur extinction. And then, let's study mammals afterwards. And the same as a writer, in a sense that doing The Rise and Fall of the Dinosaurs as a pop science book, what do you do next? If I want to write another one, what do I do next? Well, the obvious thing to do is to pick up the story after the dinosaurs died, as the mammals take over, and then circle back and tell the whole story of mammal evolution, of 325 million years that, through lots of twists and turns, through the evolution of, hair and milk and molar teeth and big brains and keen senses and all of these things in our ancestors that eventually led to us. So I think that's the natural evolution part as a scientist and a writer. But you're also correct in that, secondly, I did feel there was a bit more breathing room with mammals. I felt that there
Yeah.
were more big questions that I could answer with mammals coming from the dinosaur side. Now, maybe a mammal researcher, somebody who's done their PhD on mammals, if they transition into dinosaurs, they might feel the same. I think there's always just naturally, if you go into a new field or a new area, you're going to see things maybe that people that are trained in that area or have been working in that area for many years, don't see. But as a researcher, it just became apparent to me that there's been all this work on the origin of dinosaurs and the extinction of the dinosaurs. And in part, that's because dinosaurs are very charismatic. They're iconic. Almost every, I should say, not every, but almost every, young person, high school student or college student, university student that gets in touch with me and says, I'm interested in paleontology. Almost all of them say, I want to study dinosaurs. They don't say, I want to study fossil corals or seashells or plants. And there's nothing wrong with those things. I mean, some of the greatest work in evolutionary theory has been based on the fossils of those things. But most young people want to do dinosaurs. It is a bit of a crowded field in that sense. And to find new areas where you can genuinely innovate or where you can bring new tools maybe from other disciplines, it's just harder to do that with dinosaurs. And there's fewer fossils of dinosaurs than mammals. And, a lot of those fossils, in a sense, are already claimed, by another researcher. So there was more, I think, creative and intellectual freedom to do new things with mammals, things that I couldn't do with dinosaurs. I think that remains. I think there's still a lot of things in mammals that will keep me occupied for a while, but down the line, who knows? That might mean I will go into something else before too long.
There's a moment in the book, too, where you talk about this a manic waltz of evolution and ecological change called the Cretaceous Terrestrial Revolution. And maybe you can unpack what the CTR is here and what led to such a great diversification in mammalian evolution around that time.
So I'll set the stage by going all the way back to 325 million years ago. And that's when the mammal ancestors split off from the reptile ancestors on the great family tree of life. And for the next 100 million years or so, these mammal ancestors, they're called synapsids because the thing that distinguished them is they had a hole in their head behind their eyes, and that hole held big jaw muscles so they could bite really strongly. But these synapsids, for the next 100 million years, give or take, they diversified into lots of different species. They actually became top predators and big plant eaters on the supercontinent of Pangaea. And then there was an extinction, a great mass extinction about 250 million years ago caused by these huge volcanoes in Russia. And that led to global warming, and that led to 95% of species, give or take, going extinct, including many of those synapsid mammal ancestors. But some synapsids survived. They made it through. And among those survivors were these things called cynodonts that were small, and they could burrow, and they had hair to cover their bodies, and they could grow really fast. They could reproduce really fast. These cynodonts emerged into this new world of the next interval of time, which is called the Triassic period, and they spun off mammals, the first true mammals. And the first, true mammals are just defined as the ones that have this new jaw configuration. There's only a single bone in the lower jaw. They're the bones that used to be there in the lower jaw. Some of the extra bones moved into the ear to help these early mammals hear better. On this new single lower jawbone was a complex array of incisor and canine and premolar and molar teeth, and there's only one set of baby teeth and adult teeth. That was associated with both mammals feeding their babies milk, but also being able to chew really well as adults. All of this stuff kind of was in place. And then when all that stuff is there, that's when, as scientists, we say those things were the first true mammals. Now, those first true mammals emerged about 230, 220 million years ago on the supercontinent of Pangaea in the Triassic period. This was the same general time that another group of animals was emerging on Pangaea, and these were the dinosaurs. So, believe it or not, dinosaurs and mammals have the same origin story. And you might not think that. There's often this conception or misconception, really, that the dinosaurs evolved, they died, then the mammals evolved. But no, dinosaurs and mammals go back to the same time and place. But dinosaurs and mammals, from that point on, their fates would be forever intertwined. and they still are. But dinosaurs had a different fate. They went for grandeur. They went big. Some of them became the size of Boeing 737 airplanes. They became the iconic, amazing creatures that I wax poetic about in The Rise and Fall of the Dinosaurs. But mammals were there, but mammals were relegated to the shadows. And for 150 million years, there were mammals living with dinosaurs. There were mammals living with Brontosaurus, with Stegosaurus, with T-Rex, with Triceratops. But those mammals could not get very big. No mammal during that 150 million years, as far as we know, ever got bigger than a house cat because the dinosaurs kept them small. The dinosaurs filled those ecological niches at larger size. They were the incumbents. They didn't allow anything new to evolve there. But the more we learn about mammals during this time, the more we learn about how sublime they really were. And the more that we recognize that, yes, the dinosaurs kept the mammals small during the Triassic, the Jurassic, the Cretaceous periods, but mammals did the opposite, and they kept the dinosaurs big. And what I mean by that is, during all that time, you never saw a T-Rex the size of a mouse or a Triceratops the size of a rat. No. Mammals held those ecological niches at small size, and the mammals were very good at it. And mammals diversified at small size. They might have been pretty anonymous looking. They might have largely only come out at night. They would have been, yes, literally in the shadows of the dinosaurs, but they were there. And there were tree climbers, and there were scurriers, and there were burrowers, and there were swimmers, and there were even mammals that lived with the dinosaurs that had wings of skin that they used to glide between the trees. And then, during the Cretaceous period, and this is now getting to your question, during the Cretaceous period, this was the time of T-Rex and Triceratops, something big happened. Something completely unrelated to mammals at first happened, and that is a new type of organism evolved. And this new type of organism was a type of plant, and it was a type of plant that we call an angiosperm, and that's just the fancy scientific name for the flowering plants. These are the plants with fruits and with flowers, the ones that we are so familiar with today. The vast majority of modern plants are flowering plants. And the vast majority of the plants that provide food for us, our agricultural species, are cultivars of flowering plants. But until the Cretaceous period, there were no flowering plants. A Brontosaurus would have never seen a flower. A Stegosaurus would have never seen a fruit. But then in the Cretaceous, these flowering plants evolved. And they evolved, and they really started to proliferate. And as they spread around the world and grew in size and diversified and so on, that created new opportunities. It basically was an entirely new food source, all of these fruits and flowers, plus the leaves on these plants that grew really fast as well. And it wasn't just the plants themselves that were a new source of food, but there were new kinds of insects that were evolving to pollinate these plants. So basically there was this new smorgasbord of, all you can eat plants and insects. And the mammals took advantage. And you see this burst of diversification of mammals in the Cretaceous period. Yes, they're still small. Yes, they're still overshadowed by T-Rex. Yes, if you were alive back then, you probably wouldn't have really even seen these mammals. They would have been scurrying around. They would have been hiding. They would have been underground. They would have been emerging only in the dead of night, but they were there. They were diversifying. They were exploding in terms of their number of species and their diets and their behaviors and so on. And this is all part of what we call the Cretaceous terrestrial revolution, this wholesale change in Earth's ecosystems that was triggered by the evolution of flowering plants. So I describe it as this manic waltz of evolution, and that's really what it was. It was this frenzy of evolutionary change. All these different groups of plants and animals were along for the ride.
What ends up happening too, and this is especially as the continents start to split and form what we know today as the main continents, is that you get areas and pockets of convergent evolution, which is always something that's confounded me. And it's just such a fascinating thing that things can evolve similar traits away from each other when you typically think of evolution as like a bifurcation of a tree with a common ancestor going divergent ways. It's crazy to think that things can evolve closer together on different branches.
Yes, It is. And there are some great examples in mammals. Some of the most prime examples of convergent evolution are seen in mammals. And it makes sense when you think about it, because this is all down to mammals that are distantly related, that end up looking similar to each other, not because they evolved from the same ancestor, but because they independently evolved the same features or the same traits. And why do they do that? Because they live similar lifestyles. And when you think about it, if you want to eat meat, there are only certain types of teeth that are going to allow you to do that. You want teeth that are like sharp and serrated, like steak knives, that kind of thing. So what you see in mammals is that you see, for instance, there's plenty of placental mammals, the ones like us that give live birth to big babies. There's plenty of placental mammals that are fast, very ferocious predators with sharp teeth and claws. I mean, dogs and cats and bears and so on. And some that were recently extinct that were even more ferocious, like saber-toothed tigers. They're all placental mammals. But there are actually some marsupial mammals that lived in Australia. These are the mammals that give birth to tiny little babies that they then raise in pouches, things like kangaroos and possums. There were marsupials in Australia that were meat eaters, and they were top meat eaters, and they were at the top of their food chains. And what do they look like? Well, they kind of look like wolves or like cats. And so they're often called, a marsupial wolf or a marsupial cat. Now, these things are extinct now, so we can't see them, but we have their fossils. And what they are, they're marsupials that are convergent on placentals. Or maybe it's the placentals that are convergent on the marsupials. Really, it's both that are convergent on each other. And why do they look similar to each other? Because they were both meat eaters. And there's many other examples. There's many independent groups of mammals that separately evolved hooves. Why? Because they were all fast runners, or they were evolving in a way of faster speed. So hooves help.
It's such a trip to think of that. And and another thing that's always intrigued me too is this, the idea of how dinosaurs, but even mammals, how they can grow to such massive sizes, and then sometimes they scale back down. Sometimes that's a result of climate and everything. So maybe you can speak to how animals can get to the sizes that they can, and then sometimes they shrink down, and then sometimes they grow again into massive bodies.
Absolutely. This is one of the most fascinating topics for me about mammals. It's something I spend a lot of time on in the Rise and Reign of the Mammals. I pick it up here and there, talking about size, whether great size or small size. Now, when it comes to great size, I think when we think of big animals, we think of dinosaurs. That they come to mind first. But one of I think it's a simple fact. It's a fact I think that we all kind of know, but I don't think we always appreciate it, really deeply appreciate it. And that is that the biggest animal that has ever lived is not a dinosaur. The biggest animal that's ever lived is a whale, a blue whale. And it's alive right now. So we share the earth with the biggest thing ever. I mean, a blue whale is the size of a submarine. These things are like 100 feet long. They weigh like 100 tons, more oftentimes. They give birth to babies the size of speedboats. They can dive, thousands of feet deep. I mean, these are just absolutely extreme, sublime, superlative animals. And they are mammals. So mammals have become the biggest things ever. Some mammals can grow to absolutely colossal sizes. When it comes to these whales, the real trick is that they live in the water, so they don't have to deal with gravity in the same way that animals that live on land do. The buoyancy of the water can support them, so they don't have to have arms and legs that need to stand up against gravity, and arms and legs that need to be strong enough to hoist their bodies around, whereas animals that live on land do. And so that explains why some of these mammals were able to get bigger than the biggest land animals. The biggest land mammals were around 18 or 20 tons in body mass, body weight. And that's these were mammals. There were some elephants, extinct elephants that were this big. And there was a really peculiar type of extinct rhinoceros that had no horns, but it had these legs and arms that looked like Greek columns. And these were the biggest mammals that ever lived on land. And they were not quite as large as the largest dinosaurs that ever lived on land. And there's lots of nuanced reasons for that really come down to the anatomy, and it probably comes down to the types of lungs these animals had. I unpack those in the book, and I won't, wax on too long about them here. But that's big size, and I really think we need to revel in the fact that the biggest animals ever are mammals. They're in our family, and they're alive today. And I think that if blue whales were extinct, and they almost have gone extinct, I mean, their populations have been decimated by probably like 99% or something. But if they were extinct, and all we had were some petrified bones, I'm sure we would hold these whales in the same esteem that we hold dinosaurs.
Yeah, like you posit, if you were looking into the future, thousands of years, and then you came across a skeleton of a blue whale, we'd look at it in the same kind of awe as we look at like T-Rex and all those giant dinosaurs, of those nature's brontosaurs, and it's just one of those things like, oh my God, like we have the benefit or the privilege of being able to, in a way, witness it right now in media res.
Absolutely. And I think we really, 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 really should cherish this more, because very few organisms, the Earth is 4.5 billion years old. Very few species have been able to say they lived with, the biggest thing ever. We're one of those species. So we need to appreciate it. We need to make sure that whales don't go extinct, that future generations don't only encounter them as dusty old bones in the museum. But I also don't want to just overemphasize or obsess about giant size, because small size is important too. And we saw that, that for 150 million years, the first mammals living with dinosaurs, they had to be small. They couldn't get big in a dinosaur-dominated world. But there have been other instances in mammal evolution where small size was beneficial. And one such instance, and we see this with many types of mammals in the fossil record, is when there is climate change, and in particular when there is a sudden global warming event. A lot of mammals respond by getting smaller, by dwarfing. And there's a prime example. About 55 million years ago, there was a huge global warming spike. This is one of the biggest global warming spikes ever. It's probably one of the most relevant global warming spikes to study in order to put our modern climate changes into context and to understand how our modern world may change, what we may expect, what we might be able to do to mitigate things. So it's very important to study this ancient global warming event. And many scientists have studied it and are studying it. And one such scientist, a guy named Ross Secord, who's a colleague of mine. He's actually worked with Tom and I in the field a lot. He's been in our cruise in New Mexico, and he leads his own cruise. He's a professor in Nebraska. Ross studied mammals of this age during this global warming spike, and he found that like a bunch of different species, including some of the first horses, they got small directly in tune with the rising climates. And if you look at the graphs, you can plot climate going up, and you have these horses getting smaller, almost in an inverse, almost perfectly, like it's a mirror image. And in fact, about 40% of mammal species seem to have dwarfed during that global warming event. So not all mammals, but quite a lot of mammals. And this seems to be a common survival trick when temperatures get hot, that mammals, that especially ones that already are quite large, they get smaller. And if you're smaller, you just, by the laws of basic geometry, you have more surface area compared to your volume. Just think about, a golf ball compared to a basketball, and that golf ball has a lot more surface area compared to what's inside. And if it's really hot, that just makes it easier to shed heat and to not overheat. So this seems to be kind of some basic laws of physics and geometry that govern the evolution of lots of different mammals. So it's the kind of thing that it's a simple kind of basic revelation from the fossil record, but it's important to understand these things. It probably does mean that today, a lot of the mammals that we live with, as the Earth gets warmer and warmer, some might go extinct. Others will probably get smaller. And we need to recognize these things. This has to be part of our conservation strategies.
Yeah, what clues from that particular warming event can help with the current disaster that man has wreaked upon the planet?
What I think is the most important thing about fossils, and the reason many of us study fossils, is that they are clues from prehistory. Now, look, most of us get into fossils, we become paleontologists, not because it's some, exclusive, high-paying, elitist job where, where we're going to become billionaires. No, not at all. You don't go into a career studying, dinosaurs or fossil mammals for that. Most of us go into it because we find them cool. I mean, a T-Rex is neat. A woolly mammoth, oh my goodness, go to a museum, stand underneath the skeleton of a woolly mammoth or stare into the skull of a saber-toothed tiger. I mean, these are emotional, moving, inspiring experiences. And that's really what gets a lot of us into paleontology and jumpstarts, a career in science. But what keeps most of us here, and the real reason why fossils are so important, is not that these things are the stars of movies and museum exhibits and so on. It's because fossils, whether it's dinosaurs or mammals or whatever, these things are clues from prehistory. These are real plants and animals that once lived, and they show us what happens as the Earth changes, how real plants and animals and ecosystems respond to real instances of climate and environmental change. And this is really valuable. This is why historians study human history, right? We want to study World War II. We want to understand the rise of fascism in Germany. How could a society, presumably or at least seemingly peaceful society, but of course one that had been, wrecked by war and by economic collapse and so on. But how is that society, give rise to somebody like Hitler? We want to understand this. We want to study this. We want to learn from this. We don't want to repeat that same mistake. Well, paleontologists are like historians in that sense. We want to study Earth history, learn from it, understand it, so we don't repeat kind of the worst things that have happened, or at least that we can mitigate some of our worst impulses. And frankly, what's happening now, the Earth is changing very quickly. Climates are changing dramatically. Temperature is rising insanely fast. Sea levels are changing. The amount of oxygen in the ocean is changing. Lots of stuff is happening. But none of this stuff is new. It has all happened before. It's just the causes that are new. Right now, this is happening because of us, because of a single mammal species that has evolved to the point where it has so much intelligence and so much ability, so much agency, that it can affect the Earth so much. But in the past, there have been times when there's been global warming caused by volcanic eruptions, for instance. 55 million years ago, that event I was talking about where the horses, they dwarfed, that was caused by volcanoes, big volcanoes that were erupting and were spewing out a bunch of carbon dioxide and methane, these potent greenhouse gases. So climate change has happened before. So let's study it. Let's understand it. That puts our modern world into context. That should give us a bit of a baseline for what to expect as our world changes, as temperatures continue to rise. It should give us targets for conservation. It should tell us that certain types of ecosystems or certain types of animals are more or less susceptible to those changes. And it should give an insight into how you come out of these intense climate changes and how the world is different. And that can help us prepare for things that maybe are, too far gone now, things that we can't reverse. There will be changes. How do we prepare for those changes? We can look to the past and see what some of those changes were. So really, this is just me saying that this is why we study fossils. We are, deep time detectives or deep time historians or whatever we want to call ourselves. And we are looking at these clues from Earth history. Each skeleton, each bone, each tooth, each footprint, whatever it is, they can combine to give this story of how the Earth has changed.
Now, as a researcher and, a man of science, like, it must be maddening when you see the clues and the evidence in the fossil record, and then you overlay that over our current time, and you see people who deny climate change, or if they don't deny it, they're like, well, it's such a slow moving thing, then what can I do in my lifetime to do anything about it? And so people just kind of throw up their hands in resignation, especially say in our more cushy first world countries, we look and we can easily ignore a lot of those island countries that are greatly affected by it, but it's over there. It's not our problem. What is it like for you to see the evidence, to see it happening, and to see sometimes as a collective a collective almost resistance or a collective resignation, given that you see so much evidence and we might have the power to stop it if we just collectively did something.
It's all politics. That's what I see. I mean,
right.
First of all, denying that there's climate change. I mean, that just
maddening, right?
Makes me chuckle because, I mean, you're denying that thermometers work because, this is something we are measuring. This isn't, it feels really hot today and it didn't seem to be as hot last year from what I remember. So the temperature, no, it's not that. I mean, we have been monitoring temperature for a very long time and we see all over the world that temperatures increase. I mean, that's a fact. That's a simple fact, that the temperature is increasing. Now, there then can be all kinds of takes on that, of course, and there are people that still try to deny that we're doing it, that it has anything to do with burning hydrocarbons and human activity and so on. It's us. It's very clear that it's us. But at the same time, it's very clear from the fossil record and geological record that these things have happened before. So I think a lot of people are, because of politics, largely, are worried that if we acknowledge this is real, we'll have to do something about it, and there's going to be an economic cost to that, and I might have to give things up, and so on. Or, the government may come in and try to control everything. Fair enough. I mean, everybody has concerns and fears for different reasons. But what I would say to folks like that is, wait a minute, let's acknowledge what's real, and let's acknowledge these things have happened before, and let's try to understand what has happened in the past, and let's use that to come up with some common sense strategies for what we should do now. I mean, no, we can't just ban all use of oil right now. I mean, that's not realistic. Yeah. I think that's what a lot of people fear, though, that this single overarching big government approach to just completely turn the world upside down. No. And we can learn from the fossil record, the geological record, to give us real information, to give real strategies. The other thing I would say is that, these things have all happened before, and it's not a matter of black or white or yes or no. You a lot of times see alarmism that, if we get to a certain point, if a temperature hits a certain point or if carbon dioxide hits a certain amount in the atmosphere, that's it, we're all done, we're screwed, it's all over. I think you see this mindset in certainly a lot of the more extreme activists, and I think a lot of the younger activists, and I understand why. I mean, when you look at decade after decade of inactivity and denial and all this political nonsense, it's very easy to become totally disillusioned. But that's a very fatal way of thinking, this nihilistic way of thinking, because if that's true, then why bother doing anything? If we're past a point of no return, why bother doing anything? Let's just let the earth burn. But we're not past a point of no return. Some action is better than no action. We need to acknowledge that climate has changed. Temperatures are going up, and some of that's not reversible. We can't just turn back the clock to what things were like, before the Industrial Revolution. That's just not going to happen. At the same time, there have been plenty of other times in Earth history where there have been climate changes of this magnitude. The Earth is able to endure it, to get through it. There can be periods of trouble, but it's not complete doom and gloom. We need to do what we can. Some action is better than no action. And I hope when I write about these things, I really try not to dwell too much on the doom and gloom. I try to set up the facts, and I end the Rise and Reign of the Mammals with an epilogue that talks about the current situation. And I don't go on for dozens and dozens of pages just lamenting all the problems in today's world. I could, because there's a lot of serious issues, but I try to keep it short. I try to keep it to the point, and I try to say, look, right now mammals, if we just focus on mammals, because that's the subject of this book, mammals are in their most precarious state since the asteroid came down and killed the dinosaurs and spared the mammals, but this is the most precarious state mammals have been. And since our species, Homo sapiens, has been moving around the world, about 350 mammal species have gone extinct. That's about 5% of mammal diversity. That may or may not seem like a lot, depending on your viewpoint, but it's not just extinction that matters. It's so many mammal species, their environments have changed. Their population sizes have been decimated. Their food sources have changed. They have been introduced. Diseases have been introduced into these populations. Some have barely ceased to exist in the wild anymore. So it's more than just extinction. So a lot of stuff is happening. A lot of mammals are in danger. And in fact, a lot of the most famous mammal fossils, things like saber-toothed tigers and woolly mammoths and mastodons and giant ground sloths and all these megafauna things, these extinct mammals, they were probably killed mostly by us, by our activities, by overhunting, by changing their environments, by declining their population sizes until they just didn't have enough evolutionary gusto to keep going. So I think we need to look into the fossil record. We need to be honest with what has happened in the past and what is happening now. And we need to use that information for good. And some good is better than nothing at all.
Yeah, and lastly, you've written, a big survey on the dinosaurs and a big survey here on mammals. Yeah, if you were to get extra hyper granular on a particular mammalian line and write a similar book about it, what might that look like? And what line of mammalian evolution or mammalian species are like, oh, that's the really juicy one?
I'll tell you what I wouldn't do first, and that would be humans.
Right.
In the Rise and Reign of the Mammals, I really keep humans just to the last chapter, and the last chapter is really a primate chapter, but one that picks up from the Ice Age and comes to the modern world. It took me a long time to write that chapter. I wanted to make sure I did it very carefully. I mean, I'm not an anthropologist. I don't study human cultures by any stretch of the imagination, and I don't study human fossils. It's really a very separate branch from even mammalian paleontology. And of course, there's a lot of sensitivities we have to take when we're talking about writing about humans. So I really tried to do my homework in writing that chapter, and I tried to not get too into the weeds there. And I just tried to tell the general story of how some apes came down from the trees and started walking on two legs, and then their brains got bigger, and they diversified, and there were lots of species of these first types of fossil humans, and then over time it was truncated just down to us, Homo sapiens, and I try to tell that basic story. I would not want to do a book about all humans. That would be such a massive undertaking. I think really only a paleoanthropologist or a science writer who could completely immerse themselves in the world of humans, and not just fossil humans, but modern day humans and human cultures and everything that comes with all the challenges that come with writing about human cultures and societies and religions and so on. So I would not write about humans. I would read that book if it was done. And I think a book like that remains to be done, something that's kind of like Sapiens, but a bit more, science and evidence, heavy, but for the earlier stages of human evolution. So if anybody out there wants to do it, I can totally encourage you to do it. If I had to choose one group of mammals to write, a longer exposition on, it's a tough one. And you kind of, caught me unguarded here. So the answer I'm going to give is it maybe a little bit too cliched, but I would say it would be whales, because whales are probably the most transformed mammals of all, the most unmammalian mammals. I mean, they really do look like fish. Let's face it. I mean, can't remember how old I was. I was pretty far along in school until I realized that whales were not fish and they were actually mammals. I think a lot of us probably have that same experience. Mm-hmm. So, but they evolved from ancestors that lived on the land. And they evolved from these little animals with hooves that were fast runners that looked like a baby deer. And these little hoofed mammals probably went into the water to hide from predators or maybe eat some food. And from these little experiments with the water, these animals became more and more suited to living in the water through natural selection over about 10 million years of time. And we have this great series of transitional fossils showing basically how Bambi turned into Moby Dick. It's an incredible fossil flip book of fossil after fossil as you see these animals get bigger and turn their hooves into fins and make their bodies long and skinny, and then make their arms bigger but lose their legs, and then evolve a fluked tail and move their nostrils back so they have a blowhole and lose most of their hair, and so on. So I think that would be a great evolutionary story. It has been told in a few books a little bit, but if I had to do like my style of treatment and kind of my style of writing and storytelling, I think I would certainly go for the whales, because they're an incredible group of mammals. They have their history is such a history going from land to sea. That was a revolution. So it would be a book about a revolution, really. And that could be a whole lot of fun. But I don't think I will do that because I don't study whales. So, I do tell that story in The Rise and Reign of the Mammals, but it has 10 pages or something. And there's other whale researchers that actually know what they're talking about. Nick Pyenson wrote a book a few years ago called Spying on Whales, which is an excellent just overall book about fossil whales today, and a look into the future. And so he does a little bit of this of writing about the fossil transition, and maybe he or somebody who studies whales can write the definitive book on the evolutionary transition of whales sometime in the future.
Awesome. Steve, the book was is a big meaty dive on mammals and mammalian evolution in the footprint, and then the years after the dinosaurs. It was a fun, informative, really great pop science book. So I just gotta commend you on a job well done, and thanks for carving out some time to come back on the show and talk all things mammals. This was fun.
It's my pleasure, Brendan. Thanks a lot for the invite. I just love talking dinosaurs with you. It was so fun to do this again with mammals, and we'll do it again, but it won't be about humans. I don't know what I'll do next and when that'll be, but I won't be about humans. I'll promise you that.
And so we've come to the end. Again, thanks for listening. Thanks to Steve, who is several hours ahead of me over in the UK. It's great stuff. Love talking to him. He's so passionate about the work. It's really cool. If you care to share, link up to the show on social, tag it at CNF Pod so I can give you the James Hetfield gift you deserve. Check out the Patreon page. We got a new one, Melissa Grenou. Awesome. Thank you. Awesome to see that. Shop around, see if there's something there that will make you want to put a few bucks in the CNF Pod coffers. Every penny counts. Lastly, BrendanO'Mara.com, is where the Rage Against the Algorithm newsletter is. Be careful. It goes up to 11. Sent off what I think might be the final version of my book proposal to the agent. It's version 5, as I like to call it. This thing started way back in February, this process. I still feel weird saying, my agent, because it doesn't feel real, and I feel like I have a feeling she's just going to fire me if this proposal sucks, and there's no commitment. There's nothing in ink. It's just she's coaching this proposal along, so she sees some promise in it. She gives it time. Suggestions are amazing. It's a far better proposal now than what I first sent in way back when. It's in a good spot, I think, but then again, I've also thought along the ways that it was in a good spot several times ago, and it turns out it's kind of like whack-a-mole. You just hit one, you think you solved that issue, and then all of a sudden up pops two more, and you're like, damn it, I thought I was close. Turns out, no, you weren't. The goal line keeps moving. You thought you were having a 35-yard field goal. Turns out it's 65, and nope, you're better off punting. Do you ever wake up in the middle of the night haunted by your book proposal or haunted by your book project? I am haunted by this book proposal, but also the book project at large. I wake up several nights a week in a relative panic about not being able to deliver on this book, especially after reading Robert Caro's memoir about writing biography. It's called Working. It's a very good book. And realizing the scope of work that goes into great biography. Now, I always kind of understood that, because I like reading the notes and references sections at the end of a lot of these books, and you get to see the Titanic research that goes into this kind of thing. But I'm also thinking, like, I'm just not going to have enough time to do that kind of research. What if it takes a long time just to lobby for the right access to people who have stonewalled me, people very close to my central figure who are basically told me to fuck off? I have 2 years to research and write this biography. There's a major anniversary in 2025, so that's really what it hinges on. So, assuming I get a book deal soon, then I have to deliver on the promise of that proposal. And the research is a lot like taking a step into the void, and you just hope a brick comes out to meet your foot so you can keep walking. And then the picture starts to kind of coalesce, but sometimes you're walking blind. It's upsetting or disconcerting. I wake up bolt upright in bed, usually between 1 and 3 in the morning. Then it takes anywhere from 1 to 2 hours, usually closer to 2, to fall back asleep, if I fall back asleep at all. I'm having a hard time organizing the research I've done to date, and I haven't dived in whole hog yet, because I don't want to. I mean, if this falls apart, I don't want to have wasted all that work. So I've just been kind of like slowly doing it. But if the deal comes through, just bang, full immersion. Maybe I should be full immersed anyway. I don't know. Maybe I'm going about it all wrong. But you'd think it'd be good about this organizing thing, since I ask journalists and biographers all the time, like, how they organize their shit. Then I don't know whether I should leave my part-time job or if I should hang on, just because it is a steady dribble of a paycheck, and there's something to be said for steadiness, but there's also something to be said that you're just kind of hiding behind the steadiness of this paycheck, minuscule as it is. But if I get a semi-decent advance, I'll probably leave the job, because even a pittance of a book advance will be likely more, or at least equal to, what I make as a newspaper editor. Well, you know what I need? You know what I really need? I need that book deal to go through, right? So I can really focus on it, because then I can really focus. I feel very splintered and fractured. It would be nice to be able to have the focus of the one thing. And I need to go on a hike, like a 7 to 8 mile hike on the Oregon coast, Cummins Creek Trail, with the dogs and the wife. It's my anniversary weekend, 12 years of marriage to a single cisgendered lady. We met in 2004, got married in 2010. So we got a campground on the coast, and we're going to spend it with Kevin and Hank, the 2 dogs, and copious amounts of Oregon craft beer. So I'm going to stay wild. You stay wild, CNFers. And if you can't do, interview. See ya.